Hello friends, welcome to follow up. In the previous video, we used problem 739 to solve problem 496. So in this video, we are going to use problem 739 to solve problem 503, next great element 2. So this problem 503 is a continuation of LeetCode problem 496. So the only new assumption is that the list is circular here. So our plan will be the following. First, we quickly digest the requirement, and then we do the coding. So actually, again, we are going to use monotonic stack. So the only thing that we are going to add is to treat this new assumption, which is actually very straightforward. So now let's look at the problem digest. So here we are given a circular integer array called nums. So in other words, the next element of this one will be the beginning one, right? So we want to find the next great number or element for every element in nums. So this is the definition of next great element, right? So which is very easy to digest. So if such element does not exist, so we're going to return -1. So let's quickly look at two examples. So in example 1, so for example 1, so next one, larger one will be 2, but 2 is maximal in this list, so it has no next larger element, so we get a -1. So for this one, so the next will be this one, right, the beginning, and then we look at 2, so the 2 will be the next larger element. So we have 2, -1, and 2. Well, for example 1, example 2, so 1, the next larger one, it will be 2. For 2, the next larger one will be 3. For 3, will be 4. Then for 4, 4 is the maximal, so there's no larger element following, so you have -1. For this 3, so if you scan from the beginning again, you get 4, right? So here the constraints are the following. First, the length is bounded above by 10 to the power 4, right? So this is a decent large number. So it depends on your algorithm complexity. It can actually fail some cases, but here we are going to use a very efficient one, so it shouldn't have this problem. So this is the range, so it's not very essential here. So with that said, let's do the analysis. Let's recall problem 739. So problem 739 basically is such a problem. So given an array, right? So for each index, you want to find after how many indices you are going to have a large element, right? If not, you're going to set that to be 0 or some other number, let's say -1. So first, here in this problem, for each element, so we're going to find after how many steps you are going to meet a larger element, and then we apply to this problem. But here, the list is circular, so we just need to consider, for example, you have 1, 2, 1. You just need to consider you add another one, right? 1, 2, 1. In other words, you double. So in other words, do nums plus nums, or if you like, you can say nums times 2, right? So you have 2 identical copies, then the 1 will be next, then 2 will be. For this, we will check all the cases, right? So then our plan is that first hyperfunction to get how many days. Let's record each index is a corresponding day. How many days you are going to meet a high temperature, right, or larger element in this problem. If not, I'm going to use a convention in problem 739, set to 0. So this is the hyperfunction. Next, apply hyperfunction to the doubled list, right? So this will be the overall plan. Let's carry out this program. First, given a generic array, so I'm going to define a hyperfunction. Let's call it next greater. This is in coincidence with the video for this problem, for solving problem 496. So given the array, so our goal is to return an array result of a similarity as array, and the result I will be for element I for array I. After how many days or indices we meet a larger element. So if no such element, we set result I to be 0, right? So this is the goal we want to achieve for this one. So this is basically a very simple monotonic stack. Stack trick. So if you are not familiar with this trick, you can check out our playlist in the channel. So it's called monotonic stack. So here, in order to use this one, first I'm going to get the length of this array. So right, this is a very routine. Initialize a result, because here we set this to be 0, so we are going to use this initialization. Very natural, right? Then initialize a stack. Then we are going to scan the list, right? So for I, let's use enumerate. In enumerate, say array. Then we are going to check the stack. Well, stack and stack. So we are going to, if the top element in the stack corresponding to a number which is smaller than y, then we are going to pop. So previous I will be stack pop. Then for this index and the corresponding element, so y will be the next great element. Or you can see after this number of steps, that is, let's see, I'll set this, previous I will be I minus previous I. So after this number of days, you are going to meet a larger element, right? So after we exit this while loop, either stack is empty, or so you have a larger element at the top that is larger than y, right? Then that element, when you look at y, you see y, it hasn't met a larger element for that element, so we keep appending to the stack, or push to the stack. So stack append I. So this line of code is correct logically. The reason you can check is you can check it for I equals 0, right? So when I equals 0, the stack is empty, right? So you didn't enter this while loop at all, right? So you need to append first push index 0 to the stack. So well, after this for loop, you are going to return the result. So this is the essentially problem 793, right? So now let's look at it here. So we apply this, so problem logic here. So because the circular assumption, so we are going to, let's first get to this n, right? This n will be the length of this nums. And then I'm going to nums equals nums, double it, right? So once you double it, so you get something like this. So I'm going to apply this hyperfunction to this nums, and then I'm going to iterate to prepare the return. So let's see. I'm going to use it as an aux, right? So you apply next greater. So applies nums, and then we are going to return and prepare return. So let's do it. For y in, let's see, for I in range n, right? So we only care about the first n elements, right? So the corresponding aux I, right, is for nums I, or for the original nums I. After how many days you get the larger element? If this guy is 0, it means no great element. So in this case, result append -1. Otherwise, so we know that after this number of days, that is aux I, right? So you are going to get a greater element. So I'm going to this one. So at this index, you are going to get an element larger than nums I. But this one can be longer than the length of this array. So we need to modulo, right? Modulo, let's see, modulo n, right? N is the original length, right? Modulo n. So then what we are going to do, I'm going to append this guy. So nums at this index. So actually, here we multiply by 2 to take care of the circular assumption. And here we modulo n is also taking care of the circular assumption, right? So once you've done this, you have prepared the return. So you just return the result. So this forms a full solution format to this problem. So if you have a clear understanding about on problem 739, solving this problem, I would say, is very straightforward. So let's first do a test, right? Our list have no append. Let's see append. That's the n, right? Yeah, that's better. It passes the first one. Now let's check the second one. It's good. So now let's test generic case. Yeah, it passes all the cases. So I would say that for this problem, we just applied the very classic monotonic stack trick to address it. So actually, if you have difficulty in understanding the solving a thought process or problem solution logic, you can review the video for problem 739, then come back again. And another remark, if you want to practice more on monotonic stack, you can check out our playlist on monotonic stack in our channel. So again, last, so when you meet problems which can use monotonic stack, you can think of some special examples as we demonstrated in video for this problem. You can think a strictly increasing sequence or a strictly decreasing sequence to see what pattern you can get or what hint you can get. So with that said, I guess, with those said, I guess that's it for this video. Thank you.